Cleansing agents. We know that the two important cleansing agents that we use in our daily life are soaps and detergents. So we are going to study in detail about soaps and detergents. First, let us study about soaps. Now, we know what are soaps. Soaps are the sodium or potassium salt of long chain fatty acids like stearic acid, oleic and palmitic acid. So, soaps are sodium or potassium salt of stearic acid, oleic acid and palmitic acid. Now, soaps containing sodium salt, they are formed by heating fat with aqueous sodium hydroxide solution. So, we know we can write an equation for the preparation of soap, that is heating fat. Example for fat is glyceryl ester of fatty acid. So, I am going to give the example with stearic acid. Stearic acid formula is C17H35 COOH. This is stearic acid. Now, to prepare soap, we have to take the glyceryl ester of stearic acid. So, the formula of glycerol is CH2OH, CHOH, CH2OH. Now, we have to take the glyceryl ester of stearic acid. So, to write the glyceryl ester, I am going to replace this hydrogen of glycerol with C17H35. So, I am going to write C17H35. Now, here also CHO, C17H35. C17H35. Now, this is our glyceryl ester of stearic acid. Now, this is treated with sodium hydroxide. Now, sodium hydroxide, we have to take 3 molecules of sodium hydroxide. We get soap. Soap is sodium salt of fatty acid. Now, the fatty acid taken is stearic acid. So, glyceryl ester of stearic acid. So, we can write the formula of soap as C17H35 COONA. We will have 3 molecules and this is called sodium stearate. So, this is our soap. Plus, the byproduct formed is glycerol. Glycerol formula is CH2OH, CHOH, CH2OH. This is our glycerol. So, this is how we can write the equation for the preparation of soap, that is sodium stearate. Now, suppose you want to prepare sodium oleate or sodium palmitate. Instead of C17H35, you have to use the formula of oleic acid and palmitic acid. Now, we know the word saponification. What do you mean by the term saponification? Saponification means it is the preparation of soap. That method, that is soaps containing sodium salts, are formed by heating fat with aqueous sodium hydroxide solution, and this reaction is known as saponification. Now, soaps cannot be used in acidic solutions since acids precipitate the insoluble free fatty acids which adhere to fabric and reduce the ability of soap to remove oil. Now, let's see different types of soaps. Types of soaps. One is toilet soaps. Toilet soaps are prepared by using better grades of fats and oils, and care is taken to remove excess alkali. Color and perfumes are added to make these more attractive. Next, soaps that float in water are made by beating tiny air bubbles before they are hardening. Transparent soaps, they are made by dissolving the soap in ethanol and then evaporating the excess solvent. Then we have medicated soaps. Substances of medicinal value are added in it. In some soaps, deodorants are also added. Shaving soaps, they contain glycerol to prevent rapid drying. Then a gum called rosin is added while making them. It forms sodium rosinate which lathers well. Laundry soaps contain fillers like sodium rosinate, sodium silicate, borax and sodium carbonate. So these are the different types of soaps. Now let's discuss why soaps do not work in hard water. You know what is hard water? Hard water contains calcium and magnesium ions. So when soap is added to hard water, the calcium or magnesium ions will replace the sodium ions. So when we write, we can write the equation as 2 molecules of C17H35COONA, sodium stearate, that's our soap, plus hard water contains calcium chloride, gives 2NaCl plus C17H35COO twice Ca, that is insoluble calcium stearate. That valency of calcium is 2, so we have to write twice. So we can see that sodium getting replaced with calcium, which is insoluble, and they separate as scum in water and are useless as cleansing agents. Now, so this is the reason why soaps do not work in hard water, because that sodium of soap will get replaced with calcium or magnesium, and we get magnesium or calcium soap which are insoluble and they get separated as a scum. Now next let us discuss about synthetic detergents. The second type of cleansing agents is synthetic detergents. Now, synthetic detergents, what are detergents? Detergents are sodium salt of long chain sulfonic acid. They can be used in acidic solution as sulfonic acids are soluble in water. Now, these synthetic detergents can be used in soft and hard water, as they can even form or they give form even in hard water. Okay, so soaps cannot be used in hard water, whereas synthetic detergents can be used in soft water as well as hard water. Now, next, classification of synthetic detergents. The first classification, they are classified into 3 types: anionic detergents, cationic detergents and non-ionic detergents. So first let's discuss anionic detergents. Now in anionic detergent, the anion part is involved in cleansing action. Now what are anionic detergents? Anionic detergents are sodium salt of sulfonated long chain alcohols or hydrocarbons. Now example for anionic detergent is sodium lauryl sulfate. That is an example. Okay, now in anionic detergent, I told the anionic part of the molecule is involved in cleansing action. Now these anionic detergents are used in toothpaste. Now the second type of synthetic detergent is cationic detergents. Here the cation part is involved in cleansing action. Now what are cationic detergents? Cationic detergents are quaternary ammonium salts of amines with acetate, chlorides or bromides as anions, and cation part possesses a long hydrocarbon chain and a positive charge on nitrogen atom. Now example for cationic detergent is cetyl trimethyl ammonium bromide. Now the structure of this cationic detergent cetyl trimethyl ammonium bromide is CH3, CH2 15 times, N, CH3, 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 bromide is Br minus. And I told cationic detergents are quaternary ammonium salts of amines with acetate, chloride or bromide as anion. Now, this cetyl trimethyl ammonium bromide is a cationic detergent used in hair conditioners. Now, these cationic detergents have germicidal properties and they are of limited use. Now, the third type of detergent is non-ionic detergent. Non-ionic detergents. From the name itself, they do not contain any ions. Now, an example is, for non-ionic detergent is when stearic acid reacts with polyethylene glycol, we get a non-ionic detergent. Okay. Now, liquid dishwashing detergents are non-ionic type. And next, so these are the three types of detergents. Now, non-ionic detergents, if you are asked to write a definition, we can give the definition like this. They are esters of high molecular mass alcohol. And an example is for non-ionic detergent can be made by treating stearic acid with polyethylene glycol. Polyethylene glycol is our high molecular mass alcohol. Now, next we are going to study about the main problem that appears in the use of detergents is that if their hydrocarbon chain is highly branched, then bacteria cannot degrade this easily. So, slow degradation of detergents leads to their accumulation. Effluents containing such detergents reach the rivers, ponds, etc. and the water gets polluted. So, these days the branching of hydrocarbon chain is controlled and kept to minimum. Unbranched chains can be biodegraded more easily and hence pollution is prevented. So, we can say detergents with straight chain hydrocarbons are preferred over branch chain, as the branch chain hydrocarbons are non-biodegradable and they cause environmental pollution. So, we try to use detergents with straight chain of hydrocarbons for cleaning. So, this is about the two cleansing agents, that is soaps and detergents. Thank you.